To solve an absolute value inequality, we're going to use a graph. So here we have the absolute value of 2x minus 3. Where is this less than 7? In our previous lesson, we actually figured out where it was equal. Those two places where x is equal to negative 2 and also x is equal to 5. And I'm going to mark that on the x-axis. So negative 2 and also 5. The answer to the inequality is going to be one of two options. It's either going to be everything that's between these two values, or it's going to be everything that is on the outside of these two values. The way I have this graph, in place of y1 is the absolute value of 2x minus 3, and in place of y2 is 7. Let's figure out where this graph is lower than this graph. So if I look over here at stuff to the left of negative 2, here's y1, and here is y2. Notice that y1 is actually above y2. That is always the case if we're to the left of negative 2. These y values are always above these. That is not what this is asking for. This is asking for the opposite. Where's this graph lower than this one? Okay, let's check between negative 2 and 5. So here's the absolute value of 2x minus 3, and here is 7. Notice that this graph is now lower than this one. This is always the case as you go from negative 2 to positive 5. The absolute value of 2x minus 3 is always below 7. At this point, I know this is my answer. I'll express it as follows: negative 2 to 5. It would also be okay to write negative 2 is less than x is less than 5. So this is the solution. But just to complete this, what if you picked something that was bigger than 5? Well, here's the absolute value of 2x minus 3. Here is the graph of 7, and notice that here again we have the absolute value is above this graph here. The answer on the x-axis are all the x's between negative 2 and 5, and that's why this is my answer. So what if we have a more complicated graph? So not just the absolute value of some function and then a number, but two separate absolute value equations. So again, in the previous lesson, we figured out where these two graphs were equal, and that was that x is equal to negative 1, and also x is equal to 9. So you can see that here, at negative 1, the two graphs intersect, and then the same thing happens again at 9. The way I have this graphed, in place of y1 is the absolute value of 2x minus 3, and in place of y2 is the absolute value of x plus 6. I want to know, where is this graph greater than or equal to this graph? Again, we only have two possibilities. It's either going to be everything between these two values, or it's going to be everything on the outside of those two values. So let's see, let's start in between this time. So I have the absolute value of 2x minus 3, I have the absolute value of x plus 6. Notice that this graph is above this graph. What this means is that the absolute value of 2x minus 3 is always lower than the absolute value of x plus 6. This is not what this inequality is asking for. Therefore, I do not want to include any numbers between negative 1 and 9. Well, what about if we're greater than 9 or if we're less than negative 1? So let's start over here. Okay, if we're less than negative 1, you have the absolute value of x plus 6. We then get to the absolute value of 2x minus 3. It's the case that this graph is greater than this graph. So yeah, I do want to include all of these x values. You could write that as x is less than negative 1, actually, or even equal to. Anytime you have an equal sign here, it'll translate into having an equal sign here. But there's more. If we look at all of the x values that are greater than 9, here is the absolute value of x plus 6. Here's the absolute value of 2x minus 3. Again, this is greater than this for all of these x values, so therefore x is greater than or equal to 9. If you wanted to use intervals, that'd be completely okay. You can say everything from negative infinity up to and including negative 1, everything from 9 going up to positive infinity. You can put that union symbol to say you're taking both pieces together, and so it's completely okay to express your answer just like this.